Hello, Math Weezers! Welcome to a new lesson episode of Just Math PH. So for today's lesson, we will be discussing or learning about graphing quadratic functions. Alam natin na ang graph ng quadratic function ay isang parabola. We will also discuss the different characteristics of the parabola. We have the domain, the range, the vertex, the direction of the opening of the parabola. I-discuss din natin ang axis of symmetry as well as the intercepts. So the graph of a quadratic function is a smooth U-shaped curve called parabola. So this is our parabola. Now, the parabola has different parts in it, or there are some important parts of it that we need to discuss. So first, we have the vertex. So the vertex is a point having the coordinates h and k. So h is the x coordinate and k is the y coordinate. So basically, vertex is a point. So in this case, the vertex here has the point 1 and -4. So this tells us that our h is 1 and our k is -4. Now, notice that there is a line passing through our vertex. This line is what we call the axis of symmetry. So notice that the axis of symmetry divides our parabola into two equal parts, and it will pass through our vertex. So since axis of symmetry is a line, so it has an equation which is equivalent to x is equal to the value of h. So this is the equation for the axis of symmetry. Next, we have the x-intercepts. So what are x-intercepts? So x-intercepts are basically points here. These are our x-intercepts. And notice that these are points of our parabola that intersects the x-axis. That's why we call them x-intercepts. So our x-intercepts are the points -1, 0 and 3, 0. So since it's a point on the x-axis, meaning our y here are zeros. Now, we also have the y-intercept. So it's not always that the x-intercept here consists of 2 points. So it depends on the case of our parabola. So in this case, we have here the two intercepts or the x-intercepts. Now, next we have the y-intercept. So the y-intercept is a point of the parabola that intersects the y-axis. That's why we call it y-intercept. So in this case, we have one y-intercept and it is the point 0, -3. So here in the y-intercept, the value of x is 0, while in the x-intercept, the value of y is 0. Now, how about the opening of the parabola? Notice that our parabola opens upward. Correct? It opens upward. So since it opens upward, it tells us that the value of a in the equation y equals ax squared plus bx plus c. Remember that this is the quadratic function in the standard form. It tells us that the value of a here, it tells us the value of a here is, the value of our a here is positive. So that is positive. Okay? So if yung A is positive, then yung parabola natin is facing upward. However, if yung A natin ay negative, okay, yung A natin ay negative or less than 0, then yung parabola natin is facing downwards. So, naalala nyo, sinabi ko last time na yung A, yung value ng A, whether it's positive or negative, tells us something. So, may meaning yan. So, again, if yung A is positive, the parabola is facing upward. And if A is negative, then the parabola is facing downward. So, if the parabola also faces upward, so it means that your vertex is considered as the minimum point. Ito yung tinatawag nating minimum point. So, your parabola consists of many points. So, may mga points dyan. Tsaka dito. So, yung minimum point natin, if our parabola faces or facing upward, then yung vertex niya is considered as the minimum point. Now, if the parabola facing downward or it faces downward, then yung vertex natin here is considered as the maximum point of our parabola. We also have the terms domain and range. Since your parabola has many points around here, then it has the points X and Y. So there are many points here represented by the coordinates X and Y. So the domains tells us the kind of numbers or the set of numbers for our X. Or these are the set of X values. So, ano ba yung mga X values or mga abscissa natin sa ating parabola? Or abscissa ng mga points ng ating parabola or X coordinates ng mga points natin in our parabola? Well, the range tells us about the set of Y values of our points in the parabola. So, I will tell you how to find the domain and the range as we go on in our lesson. Following examples state whether the parabola opens up or down, whether the vertex is a maximum or a minimum point. So we have here the quadratic function in the standard form. So do not forget that we have to write the equation in the standard form or the function in the standard form for us to identify the value of A. So our A here is equivalent to 2 and it's positive. So meaning our parabola will open upward. So parabola opens up. So since the parabola opens up, then our vertex is a minimum point. Or vertex is a minimum or vertex is minimum. Okay, so remember if parabola opens up, so your vertex is considered as the minimum point. Next example, y equals 4 minus 3x squared. So this is not written in the standard form. So writing it in the standard form, that will become y equals negative 3x squared plus 4, where our a is equivalent to negative 3. So since this is negative, that is negative, Therefore, our parabola is facing downward. And since it's facing downward, our vertex is considered as the maximum point. Or it's the highest point of our parabola. So in determining the vertex HK, we have to remember that the quadratic function should be in the standard form y equals ax squared plus bx plus c. So to find the value of h, you have to determine the values of a, b, and c and solve negative b over 2 times a. So that will be our h. Afterwards, we will substitute the value of our h to x. So meaning we will replace our y here with k. So that becomes k equals a times your h become the h squared plus b times h plus c. So since h is our x, so we can replace our x here with the value of our h. And our k is the y, so we can replace y here to be the k. Then that's how we will solve for the h and the k. And for the axis of symmetry, since it's an equation of a line, so it is the equation x equals h. And for the minimum or the maximum value, it will always be the value of the k. Minimum if the parabola opens upward, and maximum if the parabola opens downward. So the k is the minimum or the maximum value. Determine if the parabola opens up or down, then find the vertex, the axis of symmetry, and the minimum or the maximum value. So we have to find these three things and then the direction of the parabola. So first, let's look at our given y equals 2x squared plus 4x plus 5. So remember that it should be in the standard form. So this is fine because it's already in the standard form. Our a is equivalent to our a is positive 2, our b is 4, and our c is 5. So we will be needing this to find the h and the k. So look at the value of our a. A is positive, therefore parabola opens up. Next, you will find the vertex, the h and the k. So h is equivalent to negative b over 2a. So that is negative 4 over 2 times 2. So that is negative 4 over 4. And that is equivalent to negative 1. So your h here is negative 1. Now let's find the value of our k. So the k is our y, so we will just replace our x here with our h, which is -1. So that is 2 times -1 squared plus 4 times -1 plus 5. So simplify that one. So 2 times, we have to follow PEMDAS, so exponent first. So -1 squared, that is -1 times -1, which is equivalent to +1. So that is 2 times 1 plus 4 times -1, that is -4 plus 5. So that's equivalent to 2 minus 4 plus 5. So 2 minus 4, that is -2 plus 5, which is equivalent to +3. So our k here is +3. So we will write here +3 for our vertex. Okay, our vertex is -1, +3. Parabola opens up. Next thing is we have to write the equation for the axis of symmetry. So axis of symmetry is given by the equation x equals h. So that is x equals, h is -1, so x is equal to -1. It is the line x equals -1. And last part, let's identify the minimum value. So since the parabola opens up, then we have the minimum value. Since parabola is facing upward, so we have the minimum value, which is k, and that is equivalent to +3. Okay. Second example, y equals -3x squared plus 4. So since this is in standard form, we can directly write our a, which is -3, and our b is 0. Our c is the constant 4. So since our a here is negative, okay, that's negative, it means our parabola opens downward. Next, let's determine the vertex h and k. So h is equivalent to -b over 2a. So our b is 0, so that is negative 0 over 2 times negative 3. So obviously that is 0, and 0 has no sign, so that is just 0. So our vertex is 0. So we still need to find the value of our k. So k is equivalent to negative 3 times 0 squared plus 4. So since this is 0, this one will eventually be 0. So we have k to be 4. So 0, 4 is our vertex. Next, the axis of symmetry. So that's the equation x equals h, so which is x equals 0, and that is the y-axis. Next is the is it the minimum or the maximum? So since the parabola facing downward, so that is downward, it means that we have the maximum value. So maximum value is the k, which is equivalent to 4. So the y-intercept of the quadratic function is equivalent to the point 0, c, where c is actually the constant c in the quadratic function y equals ax squared plus bx plus c. So it's very important that we know the value of c, and then we would just replace it with the ordered pair 0, c. So we know that the y-intercepts has the values of x which are 0. So example, find the y-intercept of the quadratic function below. So first, y equals 2x squared plus 4x plus 5. Our c here is 5. So our y-intercept is the point 0, 5. Next, in the second equation, y equals negative 3x squared plus 4. Our c here is 4, positive 4, meaning the y-intercept will be the point 0, 4. And number 3, y equals 2x squared. Our c is 0. Therefore, the y-intercept is the origin 0, 0. The zeros of the function can be found by letting the y to be 0. So that becomes ax squared plus bx plus c equals 0. And then we do the same process as finding the roots of quadratic equation. So the zeros will help us find actually the x-intercepts. Now, example, find the zeros of the quadratic function y equals x squared minus 3x plus 2. So we will let our y to be 0. So that is 0 equals x squared minus 3x plus 2, or that is x squared minus 3x plus 2 equals 0. So let's solve this using Vedic. Our a is 1, our b is negative 3, and our c is positive 2. Okay, that's positive 2. So solving using Vedic, we have to multiply our a and c, so that is positive 2, and let's find two numbers that if we add them, it will be negative 3, our b, and if we multiply these numbers, the result will be positive 2. So that would be -2 and -1, because -2 times -1, that is +2, -2 plus -1, that is -3. Next, we will divide it by our a. So divide by a. So that becomes -2 and -1. And do not forget to flip to get the roots. So the roots are 2 and +1. These are the roots. Therefore, our zeros of the function are 2 and 1. It also means that the x-intercepts, remember that in the x-intercept, we let our y to be 0. So these are the x values here. So x-intercepts are 2, 0 and 1, 0. So first, let's replace y to be 0. So it becomes x squared plus 4x minus 2 equals, so let's make y to be 0. So for us to determine if this quadratic equation is factorable, we can use the concept of discriminant. So if the discriminant is non-perfect number, meaning we have to solve this using the quadratic formula. So discriminant is given by b squared minus 4ac. So let's identify our a. Our a is 1, our b is 4, our c is -2. So b squared, so that is 4 squared minus 4 times a times -2. So 4 squared is, that is 16. -4 times 1 times -2, that is +8. So 16 plus 8, that is 24. And since this is a non-perfect number, meaning this equation here is non-factorable, so we are to use the quadratic formula. So do you still remember the quadratic formula? So the quadratic formula is denoted by x equals -b. We have to memorize this: plus minus square root of b squared minus 4ac over 2a. So our b is 4. So -b, so that becomes -4 plus minus square root of, we already solved this because this is our discriminant, which is 24 all over 2 times a, which is 1. So 2 times 1. Okay. So -4 plus minus square root of, so 24 is a non-perfect number, but it has a factor that is perfect. So the factor is perfect that we can extract its root, that is 4 times 6 all over 2. So that is -4 plus minus, so the square root of 4 is 2. So once it goes outside, it becomes 2. So plus minus 2 square root of 6 over 2. So we can still divide negative 4 to 2 and 2 here to 2. But it's not possible to divide 6 to 2 because this is placed inside the radical symbol. So only the 2 outside can be divided by 2. So that is negative 4 divided by 2, that is negative 2, plus minus 2 divided by 2, that is 1, square root of 6. So we can make 1 to be invisible. So that is negative 2 plus minus square root of 6. Therefore, the zeros are the roots. So the zeros are negative 2 plus square root of 6 and negative 2 minus square root of 6. We have read the characteristics of the parabola when it is facing upward. So example, this one. Now, if it faces upward, meaning A is greater than 0, it's positive. So we know that already. Next, the vertex, the axis of symmetry. Now this one here means that if the absolute value of A of that quadratic function is less than 1, meaning the parabola will become wider to its graph when A is 1. So we have here a parabola where A is equivalent to 1. So if we solve the absolute value of A and it is less than 1, it means the parabola will become wider. So it will be wider than the parabola when A is 1. So this one is wider. Now if the absolute value of A is greater than 1, the parabola is actually narrower. So it will be tight compared to the graph when A is equivalent to 1. So this is actually narrower. Okay, next we have the Y-intercept. So this is the 0, z, and the zeros of the function. We know that already. Now the domain is the set of all real numbers. So we can use a symbol, this one, that means all real numbers. So the range are the values of the y, or the set of the values of y, and the values of y would always be, when it is facing upward, y is greater than or equal to k. So this is the format in writing the values of the range. So y is greater than or equal to k if the parabola is facing upward. And the minimum value, since it is facing upward, the parabola is minimum, and the minimum value is the k. For example, determine the characteristics of the quadratic function y equals 2x squared minus 2, then graph it. So since this is already written in the standard form, we can identify the values of a, b, and c. Our a is 2, our b is 0, and our c is negative 2. So I prepared tables here already. Since our a is positive, this is positive, meaning our parabola opens upward. Then the vertex is 0, negative 2. So how did we do that? So we solve for h. The h is the x coordinate of our vertex. So h is negative b over 2a. So negative 0 over 2 times 2. So obviously this is 0. That's why our h is 0. And then to solve for the k, we will substitute 0 here. So 2 times 0 squared minus 2. So that would become 0. So k here is equivalent to negative 2. So our vertex is 0, negative 2. Next, our axis of symmetry, which is x equals h. So this is actually x equals h. So h is 0, so x equals 0 is our axis of symmetry. So our a is 2. Absolute value of 2 is positive 2. And that is greater than 1. So if absolute value of a is greater than 1, meaning the graph of our parabola or the graph of the quadratic function is actually narrower compared to the graph when a is equal to 1. And the y-intercept is 0c. So that is 0c. So our c is negative 2, so that is 0, negative 2. The zeros of the function, these are actually the roots of our function. So solving for the roots, we have negative 1 and positive 1. Okay, let's solve it. So 2, negative 2. So that is negative 4. Then we are looking for two numbers that if you multiply is negative 4, but if we add, the value will be 0. So what are those two numbers? So obviously these are 2 and negative 2. Because if we multiply that, that is negative 4. If we add that, that is 0. So we divide it by our a. So our a is 2. Our b is 0. And our c is negative 2. So a is 2. So divide it by 2. So that is 1 and negative 1. Then do not forget to flip. So that is negative 1 and positive 1, which becomes our roots, and that is actually our zeros. So negative 1 and positive 1. So it also tells us that the x-intercepts are negative 1, 0 and 1, 0. These are our x-intercept. So the domain are all real numbers. Okay, and the range are the values which are greater than or equal to k, which is negative 2. So y is greater than or equal to negative 2. And the minimum value, since it's opening upward, so the minimum value is the k, which is negative 2. The quadratic function, we will be using the vertex. And for our points, the vertex, the y-intercept, okay, the y-intercept and our x-intercept, or the zeros of the function. So actually 3 points is enough as long as it formed the U-shape curve for the parabola. So we have the vertex, which is 0, negative 2, 0 here. Our y is negative 2. The x-intercept is the negative 1 and positive 1. Negative 1, 0, and positive 1, 0. So these are our zeros, or the x-intercept, and this is actually the vertex, and at the same time it so happens that it's also our y-intercept. So let's graph it. This is our y. Okay, let's plot negative 1, 0. So this is our negative 1, 0. 0, negative 2. Okay. Okay, this is our 0, negative 2. Okay, negative 1, 0. 0, negative 2. And then 1, 0. So, since it formed the U shape curve, so this is enough for our graph. So all we have to do is to connect them. Okay, connect them. Okay, smooth U shape curve. Okay, so this is the graph for y equals 2x squared minus 2. So how about the axis of symmetry? So the axis of symmetry is still the y-axis. So this is our axis of symmetry. X equals 0. These are our x-intercept. And this is also our y-intercept, which is our vertex. And this line is our axis of symmetry, x equals 0. Next is the characteristics of the parabola when it is facing downward. So obviously our a is less than 0 because it is negative. So next we have so it's actually more or less the same with the characteristics of the parabola is facing upward. Dito lang sila nagkaiba for the range. Okay, so for the range, the values of y here are actually less than or equal to k. If it's upward, y is greater than or equal to k. And also here, since it's facing downward, it should be the maximum value. So the k is the maximum value in the parabola. We have the next example, y is equal to negative 3x squared plus 6x minus 3, where our a is equivalent to negative 3, our b is positive 6, and our c is negative 3. So since our a is negative, so our parabola is facing downward. So for the vertex, we have 1, 0 because h is equivalent to negative b over 2a, and that is negative 6 over 2 times negative 3, that is negative 6 over negative 6, and that is positive 1. So we will replace our x here with 1, so k is equivalent to negative 3 times 1 squared plus 6 times 1 minus 3. So that is negative 3 plus 6 minus 3. So that is positive 3 minus 3, which is 0. So that is why our vertex is 1, 0. So x is equal to h. So h here is equivalent to 1. and our k is 0, so x is equal to 1. Now the absolute value of negative 3 is 3, which is greater than 1, so the graph that we will be having later is narrower compared to the graph when a is equal to 1. So since our c is negative 3, so 0, negative 3 is our y-intercept. And the zeros of the function is 1. So why do you think that is 1? So let's solve it. Let's erase this part. So multiplying our product is positive 9 and the sum is 6. So let's find two numbers that when multiplied is 9, but if we add it is 6, so that is 3 and 3. So 3 times 3 is 9 and 3 plus 3 is 6, divided by our a, which is negative 3. So that is negative 1 and negative 1. So since they are the same, if we flip it, that is just 1. So this is our 0. So it means that our x-intercept is 1, 0. So the domain are all real numbers and the range is y is less than or equal to k, which is 0. So y is less than or equal to 0. So since it's opening downward, we have the maximum value of k, which is 0. So this is our vertex. It so happen it's also our x-intercept, or the 0 of the function, 1, 0. So this is also our 0. And here we have the y-intercept. So we need another point so that it will be a U-shaped curve. So for us to know what point we will choose, we have to first plot it, or plot this point. So we have 0, negative 3. So 0, negative 3 is here. And 1, 0. This is 1, 0. So basically these are vertex, so it would look like that. Let's use another color. So it would look like this, since this is our vertex. So we need another point here to make it a U-shaped curve. So let's choose the point, or the x. Okay, so that it will be balanced, we will choose the point 2, x to be 2. So if x is 2, y is obviously negative 3. Correct? So let's check it by substituting 2 to x here. So if x is 2, y is equivalent to negative 3 times 2 squared plus 6 times 2 minus 3. So this is negative 3 times 4 plus 12 minus 3. Okay. So that is negative 12 plus 12 minus 3. So that's cancelled. So our y is negative 3. So we are correct. If our x is 2, then y is negative 3. So we can complete our parabola. No. Okay. Then put an arrow here. So how about the axis of symmetry, which is x is equal to 1? So let's make a line here passing through the vertex. And that is the equation x equals 1. So this is the graph of the parabola y is equal to negative 3x squared plus 6x minus 3.